At some plants once in a while.
That's what?
At some plants, some factories.
Yeah, sometimes that can be an issue because that gets you a little less, certain drives will trip out because it's beyond the tolerance, but other ones, I mean, if you're running at that higher level all the time, you run the risk of reducing the service life of some of the components too. Now, on the other hand, you are drawing less current at a given time than the other application, but still it gets a little bit, but sometimes there's a voltage limit to what components can tolerate as well, and you want to be careful of that.
Don't you got a lot of that wild, what they call that, B-phase, or you got that one leg of power that's...
Stinger leg?
Stinger leg, yeah.
Yeah, I've heard of that. It's the wild leg where you have, let's say...
It's on an old Y, off an old Y system.
Yeah,
okay.
I know he's got several of them, up by Gary and Hammond and all that, that's got that going on.
Lafayette's got,
Do they?
Lafayette's and Lafayette's got a bunch of them.
How do you control that?
You pretty much, I guess, you don't control it so much as you have the ability to tolerate and work with it. And we have had mixed success on that. I think if the worst case, you may end up having to oversize the driver rating for a given application. I've heard the wild lag, and I guess that's power companies, that's a way for them to run power cheaply. Get less cost to them out of the field, even though it does create these oddities. And some equipment's more tolerant of that than others.
They're getting away. Around this area, they're getting away from it.
Right. Well, yeah, and the other things they put in the drive now is the ability to detect a brownout and either run at a reduced load or actually stop and suspend action. And then when the brownout's over, it can just pick up automatically rather than you having to go out and restart it. So
That was
it's in
the
a
other
state of
thing.
suspension.
That's nice.
Yeah, that was the other thing I wanted to ask you about was, I've heard it called a flying start.
Ah, yes. I was just thinking of that as I mentioned how you have your wind tower and you have the blade there and it's still spinning because of the wind or whatever, or something up on a rooftop subject to the wind. It's spinning, it might even be spinning in the opposite direction of what it normally runs. So when you start it up, if the drive assumes that the fan's at rest when it starts up, and it just starts ramping up, you can see an enormous current draw. But the drives do have the capability to say, they call it a fly catcher, catch a spinning load. I've heard a couple other terms. Basically, it's doing a speed search right at the start to see if if there's actually some motion on the fan, and then
I'll have to call you back.
it takes and detects the moment, the speed at which it's running, and then takes things from that speed rather than assumes it's zero. Yes, we do that. We do have that capability in our drives.
I've had an issue a place or two where just momentary loss of power and boom, I didn't want to restart until you
Right, yeah, that's
enable that
another
parameter.
situation is that we have something else on the drives. We call it DC injection braking, and what it does is towards the end of a deceleration cycle, you get some low voltage DC. Just open up the transistors and just keep them open and put a low level of voltage out DC. That tends to take the shaft and lock it in place, so that if you have something you stop, it's all stop, but there's a lot of momentum, you can hold it in place like that. What we can do that on the front end as well. You start accelerating a product, but rather than just starting the straight 0 to 60 hertz, you go to maybe 2 or 3 hertz and you hold it in place with some holding level of DC injection at start, and then you take off. Well, we can use that first of all for to make sure the load is at rest or where we think it is, but also that would be a crude form like if you have a damper actuation circuit that they put in and you didn't really have to control them. It's one of the things where you get the run command, but you're supposed to wait until the dampers actually move into place, and so you need to buy some time. And the DC injection braking circuit can help you there too, in that function. So, Any other questions on anything? Like I said, the one thing I didn't mention, the M3 drive, that's a nice compact drive. It's good for retrofits. It's got a lot of the same capabilities we were talking about as far as the ability to follow a PID loop. It's got BACnet built right into it by configuration process. That keypad is removable, and you'll notice in the picture it does have a pot right on the front potentiometer.